Cteck-Sbs will present before you a topic on immobilization of enzymes and cell, a very important topic of cell biology. What is immobilization and why it is done? Cells or enzymes are confined or anchored in or an inert spot for their stability and functional reuse. There are certain biological processes which are conducted so as wherein enzymes or cells are used. So these cells are confined or anchored on an inert spot with which they do not react. They only react with the substrate or act on the specific location for which it is used, and they are anchored on the support in such a manner that they are stabilized and they can be functionally reused also. The immobilized enzymes retain their structural conformation which are necessary for catalysis. The immobilized enzymes yield specific products in pure form. Immobilized cells possess the natural environment with cofactor availability. They are suitable for multiple enzymatic reactions. Now, there are certain advantages of immobilized enzymes in which they are used in different bioprocesses. One is a stable and more efficient function. Products are enzyme free. They are ideal for multi-enzyme reactions. They are suitable for industrial and medical use. They minimize effluent disposal problems. Just because they are entrapped, they are conjugated with a membrane, they produce less effluent because substrates are in contact with them for a very shorter span of time. So the cells do not get time to get effluents. They do not release effluents in a shorter span of time. Now, the disadvantages. Every process has one advantage and a disadvantage. So the disadvantage of immobilization is that the biological activity may lose during the immobilization. Expensive and requires sophisticated equipment for the processes. It's a very expensive process due to the money involved in the conjugation of the enzymes and the living cells with the membrane. Now we'll discuss one by one the methods which are involved in immobilization. The first method which is involved is known as adsorption. Adsorption means over the surface. So it is a physical binding of enzymes or the cells on the surface of an inert support. They involve weak forces such as van der Waals forces and hydrogen bonds so that the enzymes or cells can be extracted and can be reused. The adsorbed materials can be easily removed by changing the pH or temperature. The inorganic support materials include alumina, silica gel, calcium phosphate gel on which the cells or the enzymes are adsorbed. The organic support materials include the starch, carboxymethyl cellulose, DEAE cellulose, etc. Second method is entrapment, in which the enzymes of the cells are immobilized by the physical entrapment inside a polymer or a gel matrix. These polymers or gel matrix have small pores inside them, which allows substrate and products to pass, but do not allow enzymes to come out of the trap. Because the size of the pores is so small that the enzymes of the cells cannot come out of it, but the substrate and the products can pass. Substrate can pass, they react with the enzyme, the product is formed and passed out. The matrices used for entrapment includes the polyacrylamide gel, collagen, gelatin, starch, cellulose, rubber, etc. There are certain types of entrapment which are used in the bioprocess, which is enzyme inclusion in gels, enzyme inclusion in fibers, or enzyme inclusion in microcapsules. That means they are either included in the gels or the fibrous membranes or the microcapsules. Major limitation is the leakage of enzymes or cells from the matrix. Sometimes the size of the matrix increases due to the high inflow of the substrate or products, and in that case the enzymes or cells can leak to the matrix. This is a diagrammatic representation of entrapment, in which the cells and enzymes are entrapped with a covalent binding, and they are covered by a semi-permeable membrane from which the substrate can pass and the products can finally form and pass across. The third method is microencapsulation. It is a process of spherical particle formation wherein a liquid or suspension is enclosed in a semi-permeable membrane. They are encapsulated in a semi-permeable membrane. The membrane may be polymeric, lipoidal, lipoprotein based. They are used for immobilization of mammalian enzyme cells. You can see the diameter of the contact surface. Usually, the drugs are microencapsulated and transferred to the membrane by the process of microencapsulation in mammals. The fourth method is the covalent binding, in which the immobilization is achieved by creation of covalent bonds between the chemical group of enzymes or cell and the chemical group of the support. So the support is bounded by the enzymes of the cell by a covalent bond. The inert support requires pre-treatment to form activated support so that it can form the covalent bonding. This includes cyanogen bromide activation, diazotation, peptide bond formation, activation by bi or polyfunctional reagents, with the help of which the covalent bond is formed between the inert support and the enzymes of the cells. Next method is cross-linking, which is the absence of a solid support. The cross-linking is introduced between the enzyme molecules. Cross-linking reagents form bridge between the two or more enzyme molecules, which form the backbone to hold the molecule. Cross-linking reagents include glutaldehyde, diazobenzidine, hexamethylene diisocyanate. The glutaldehyde is the most extensively used cross-linking agent. It reacts with lysyl residues of enzyme and forms a Schiff's base. It is an irreversible process, successfully used to immobilize industrial enzymes like glucose, isomerase, penicillin, amidase, etc. The advantage include that it is simple and cost effective, and the disadvantage is the risk of denaturation because it is an irreversible process. These are the different methods of immobilization: adsorption, then the covalent bonding, the entrapment, and the cross-linking. Now, the effects of immobilization on enzyme properties. Sometimes substantial decrease in the enzyme specificity is seen. Sometimes their reactivity is lost. Km and Vmax varies from native enzyme. The native enzymes Km and Vmax is different, and after immobilization it is different. It varies. The affinity towards the substrate may change sometimes. Usually it is a reversible process, so once after the process is over and is reused, and sometimes affinity towards the substrate may change. So different substrates are used for immobilization. The immobilized enzyme reactors are the batch reactors, which operate in batch mode. Packed bed reactors are generally used because of the conjugation which is done between the enzyme and the substrate and the membrane. And the stirred pack reactor are also used for a proper reaction to occur. Continuous reactors are used in which the substrates are added continuously and products are removed simultaneously. Example includes the continuous stirred reactors and packed bed reactors. Advantages include control over the product formation because the samples are checked on a daily basis. Sampling is done on a daily basis so as to check the immobilization, the formation of the product. They are easily automated because on a daily basis, on a particular time frame, the products are extracted and the substrates are added. They are efficiently reused, and the cells and the enzymes can be reused for the next process of immobilization. There is the membrane reactors. Several membranes with variety of chemical compositions are used. Example, polysulfone, polyamide and cellulose acetate. The enzymes of the cells are retained on the membrane. Substrate is introduced into reactors where the product passes out, which can be recovered. Good mixing in the reactor can be done by using the stirrer. Immobilization of cells. Individual enzymes are not suitable for multi-enzyme reactions and enzyme reaction requiring cofactors. The immobilized cells have been traditionally used for the treatment of sewage. Technique used for immobilization of cells are entrapment, adsorption, microencapsulation, covalent binding and cross-linking. The prokaryotes are mainly used in process of immobilization because they are effective to use and do not lose their reactivity easily. There are certain examples of the immobilized cells and the industrial application. For example, E. coli when entrapped is included in the production of aspartic acid and tryptophan. Pseudomonas species used for the production of L-serine from glycine. S. cerevisiae is included in the hydrolysis of sucrose production of alcohol. Zymomonas mobilis is used for the synthesis of sorbitol and gluconic acid. Humicola species is used in the conversion of rifamycin B to rifamycin S. And bacteria and yeast are used in different processes in the biosensors. So there are certain examples which need to be learned for the examination. Thank you, student, for going through for this presentation on immobilization of enzymes, the bioprocess technology. You can watch more videos for free at www.cteck-Sbs.org. Students, CSIR June 2013 examination is coming up and the time frame is very less to prepare. So you can start your preparations full-fledgedly by joining Cteck-Sbs classroom coaching program, which is an online classes wherein you can attend the classes sitting at your home.